Welcome to 2.2 Linear Equations. Today we're going to identify linear equations and functions and write linear equations in standard form and graph them. So to start with some vocab, a linear equation is just an operation that other than addition, subtraction, multiplication of a variable and a constant. It does not contain variables with exponents other than 1. That's the key right there. It does not contain variables with exponents other than 1. So this is a linear equation. 5x minus 3y equals 7. Notice that x and y both have variable or exponents of 1. Okay. This is not a linear equation because b has a squared, which is an exponent, not 1. Okay, so that's linear. A linear function is a function whose ordered pairs satisfy a linear equation. X and y intercepts, so the y-intercept is where the graph crosses the y-axis, the x-intercept is where the graph crosses the x-axis. So our example 1, we're going to identify linear functions. So a here, 10 minus 5x, that is a linear function because x has an exponent of 1. B is not a linear function because x has a power of 4. And c is not a linear function because it has that multiplication in there. In August 2000, the Russian submarine Kursk sank to a depth of 350 feet in the Barents Sea. Linear function p of d equals 62.5 d plus 2,117 can be used to find the pressure, pounds per feet squared, at a depth of d feet below the surface of water. So A, we're going to find the pressure at a depth of 350 feet. So we're going to start with the original function. Then we're going to substitute 350 feet in for d, because d is our depth. Okay, and then we're going to simplify. So we get 23,992. So the pressure at a depth of 300 feet is about 24,000 pounds per square feet. Okay. The term 2,117 in the function represents the atmospheric pressure at the surface of water. How many times as great is the pressure at a depth of 350 feet as the pressure at the surface? So we're going to divide the pressure of 350 feet below the surface by the pressure at the surface. So the pressure at the surface is if d was 0. So the pressure would therefore be 2,117. So we're going to do 23,992 divided by 2,117. And that's about 11.33. So the pressure at the depth is more than 11 times as great as the pressure at the surface. So here's our standard form of a linear equation. It's ax plus by equals c, where a is greater than or equal to 0, so positive. A is positive. A and b are both not 0. Okay, so we're going to write the equation in standard form, identify a, b, and c. So we have the original equation first, and then we're going to add 2x to each side. So we got 2x plus y equals 3. So therefore a is 2, b is 1, and c is 3. Okay, in our next one, we have the original equation, negative 3/5 x equals 3y minus 2. We're going to subtract 3y from each side. We're going to multiply each side by negative 5 so that the coefficients are integers greater than 0. So we get 3x plus 15y equals 10. Therefore, a equals 3, b equals 15, and c equals 10. The last one, we have the original equation, 3x minus 6y minus 9 equals 0. We're going to add 9 to each side. Then we're going to divide each side by 3 so that the coefficients have a GCF of 1. So we get x minus 2y equals 3. Therefore, a equals 1, b equals negative 2, and c equals 3. Okay, so that was standard form. Example 4, our last example, we're going to use the intercepts to graph a line. Find the x-intercept and the y-intercept of the graph 3x minus 4y plus 12 equals 0. Then we're going to graph the equation. So we start with the original equation. We're going to substitute the values, we're going to substitute 0 for y to find the x-intercepts. Okay, so we got 3x minus 4 times 0 plus 12 equals 0. That negative 4 times 0 is 0, so we got 3x plus 12 equals 0. We're going to subtract 12 from both sides, so we get 3x equals negative 12, therefore x equals negative 4. So the x-intercept is negative 4. The graph crosses the x-axis at negative 4, 0. Likewise, the y-intercept is the value of y when x is 0. So we're going to substitute into our original equation 0 for x. So we get negative 4y plus 12 equals 0. We're going to subtract 12 again, so we get negative 4y equals negative 12. Divide each side by negative 4, so y equals 3. The y-intercept is 3. The graph crosses the axis at 0, 3. We're going to use these ordered pairs to graph the equation, where we put negative 4, 0, 0, 3, and we connect. That is it for 2.2. Good luck on the practice.